Hello fellas, welcome to another video here on this journey about the Redux, specifically with Redux advanced features, which is this RT key. And what are the not only the philosophy, the design, and the goal and intentions that we're gonna briefly describe that, but also is that as we describe this, as we understand what is the end goal of the Redux and what is the problem that it solves or is trying to solve, which is now provide the ability to now keep track is the state of our application. So we can now not only have the ability to know at which state our application is currently at, but also have the ability to debug that, to see, thanks to all of these particularly nice little features that they come up, they provide to us. So for example, like Redux DevTool, like we can do this now time travel debugging, and understand that the Redux, all right, at the end of the day, is now this particularly library that allows us to manage the state of our application, useful especially for front-end applications. It also now for backend, as well as to know at which state do we have now in our applications, or at which particularly piece of data we need to keep track, and then to synchronize from the server into the backend, right? And in the case of the front end, how we can now synchronize this data with the user. So this is a very interesting process of how you can now synchronize data back and forward and so on. In our particular case is with these front-end applications. That's one of the reasons why I also look at other courses from Yves Ray, which is a software engineer that previously worked at JetBrains and now he's currently at Meta, where he now describes what is the fundamental of front-end system design. If you're going to be a UI specialist on that, what are the basic things that you need to do, know, and work as a way to provide this front-end UI solutions to clients. And also, when it comes to actually is maintain that applications, how can we use now, or there is another course as well made by Steve Kinney, which is the head front-end engineer at Temporal, and he previously worked at Twilio and among other companies. But now he gave us in that particular course what are now the things that we need to consider, what are the fundamentals that we need to do, especially when we want to make this enterprise UI developments. How can we now, instead of designing something, which is a great thing, which is also important, okay, but also now how can we make that maintainable, all right? And what is maintainability means? This is not a course about that. This is just a way to recognize these two particularly courses that actually are now part of my arsenal, and you can also take a look at your from front-end master, which is now front-end system design, which is something that a lot of companies are actually looking at that, because they want is just to recognize, hey, good that you know all of these nice little hacks, especially when working with streams and algorithms and that kind of thing. But now we need you to know is that, especially for front-end applications, is that, hey, I want you to know how we're going to build these applications, right? So we want to know as a company, from the company POV, if you really know about the stuff that you know or that you have worked, and also you know the trade-off is that, hey, how is your analytical process? How is your communicational and your technical skill? Is that, hey, do you memorize everything or do you know the trade-off? Also, your coding skill is a way to look at the algorithm and data structures, okay? And also is the communicational skills, right? So, but in any case, this is one of the course. The other course is the enterprise UI development. Okay, I actually take note of both of these courses. I'm currently looking at this course and actually are recording some of this series of videos. It's very, very interesting as a way to now, not only from the soft skill perspective, but also for the technical perspective, is that how you can make sense of all of this in the most concise manner. So, in any case, all right, because here is now talking about this rethinking asynchronicity in JavaScript. We came to this because what we're writing is this Redux application, this way of how we can manage the state of our application. And Redux actually, the core philosophy and goal is to make the state management mutable, which is a very interesting read from the Tao of Redux, made by one of the maintainer of Redux, okay, which is what is the intent and design of Redux, as well as the design principles, or in this case, first is the Redux influence and goals, and then the design principles and intent. So by making this state mutation predictable, okay, using is the flux architecture, where this flux architecture is the way, let me hear this, flux architecture, and the flux architecture, let me see, from flux, exactly, from the website, all right, the flux architecture here, flux application architecture. I'm not sure if they added to that, because actually this is an architecture, a way of how you can build this kind of applications here. Getting started. Okay, but this is no. Yeah, I just want to let me see if the flux architecture, let me see architecture, Dan Abramov, the prior art, a new course by Mark Edison plus UI Dev. What the hell is this? Has a mix of heritage, influence, flux, exactly. But you're gonna take me to that. Exactly, flux architecture for building user interfaces. That's right. But I don't think they actually show the this one, exactly, this one. This is just what I want to actually get from that. And in fact, let me actually is in the advanced Redux, specifically on the recap about Redux here, which is Redux fundamentals here, okay, which is one of the reasons why actually we are looking at this and describing is now the Redux API, Redux store, and all of this. This is Redux influences and flux architecture. Okay, this is part of the flux architecture. So yeah, is you have. So now this is the way of how you can actually create a single flow with a single flow of data, right? As a way to have now a mental model of how can we now, using this architecture, this way of building things, in this case to maintain the state management, how by using this architecture, it actually gave us an outcome, which is make the state updates maintainable. All right. So anytime we make an update to the view, to the UI, all right. So for example, the user now, um, the user want to know is their order history. Let's say you are implementing an e-commerce and they want actually is to so in this e-commerce, which is something that you see a lot of the time, you have now this order history as a timeline most likely, where in there you can see at which current state now is your package, right? Let's say you order some food cats or food dogs, all right? You want to know when they're going to arrive. So if you're using Amazon Prime, which is a great thing, it actually is you're gonna get that at the same day. Depending of which Amazon Prime you use, I think Amazon Prime, right? Amazon Prime here. Amazon Prime, yes, no, Amazon same day delivery. All right. So yeah. So with Amazon same day delivery, you can actually see that, or for any time you actually is purchase something and you want to see the order, this is now the way of how you can is, for the developer's perspective, show this in a relevant order. So not only that you can now also to show all of these different states, and actually check when the current at which state of that package is, all right, whether it is, hey, this is already in the on the yards, or they have been dispatched out of the yard, they are on your way, that kind of thing. So the point of this, by looking at this kind of things, that allows you to is now maintain and keep track at which state your order from the user perspective is, and from the developer perspective, now it can have is this controllable way of how it can show this particular data. When it comes to actually is handling a synchronicity, okay, that's when things started to get very interesting. And again, this is now a separate set of problems. This is a separate nature in itself. That's why we first started to we look now at how can we create. So what is Redux at the end of the day? This well-battled test state management applications, and look at what is the Redux is made of, what is the component of this Redux API is made of. So you have now the create store, and from there we also look at the compose, which is part of the concept that now comes from Redux, because at the end of the day, the Redux intent is to use the Flux architecture as a way to make the state management predictable, and that's one of the goal of Redux. Also, by using the Redux architecture, or this Flux architecture, where you can now have your actions that dispatch now. So you have now your action that dispatch something to the store, and then the store gets updated to show that on the view, which is the reason why actually showing is this particular diagram, okay? But if you want to now or create now a more way of how you can propagate states here, okay, is that based on the view you can actually detect again the actions that is going to dispatch now that is going now to pass to a dispatcher model that actually is responsible to now that based on the action that it received is going to update the state in your store. So your store is now the place where it hold all of this data, and you're going to now update those states using is now this action history, using is now this action and dispatcher, Also, we're going to use is the action history as they mentioned here, right? The using is the action history because this action history this action history should be semantically meaning as a way to, when it comes to debug or understand what were the chains that modified this state, we know what action was, and also introduce to some sort of the functional programming principles, right? As a way to now make our code not only testable, easy to maintain, but also by putting this constraint, where constraints give you a lot of the time in computer science, give you a particular outcome, very efficient. So for example, in the case of stacks and queues, this is more for data structures, they provide you now is very quick access time, whether it's in the case of the stack, first in, first out, or in the case of queue, first in, first out, and in the case of queue is like first in, last out. Very strict specific constraints as a way to now understand how do we get here. Okay. But in any case, okay, that's one of the value proposition of the Redux, okay? Make the Redux function should be organized by state slice. Here is actually combines all of this. This is part of the Redux architecture. And again, because we were looking is at how can we now create is this Redux API, how can we use this Redux API, what is the problem that it solves, how we starting to see is now this particularly functional programming that is that defined here as a set of constraints to make this state management maintainable as a top priority. So that's why we have concepts like compose and then immutability and serializability, right? So after we look at how can we now create this Redux store, add some states and update that particular state with some of the function that they provide, okay, by the store. So for example, dispatch and subscribers, the kind of thing, and also how you can now is compose several of these actions in a way that is much more easy to work with JavaScript, of course, easy to work, and also when it comes to actually is combine your reducers or this update state logic. So the action is the one who say, hey, this is the action that we want to, this is the action that we're going to do to mutate the state, and this is the payload. The reducer function say, all right, now let me actually mutate that state in a way that is much more easy for developer perspective, which is returning is now in a pure way, okay? So some of the concepts like purity as well as partial application and currying, what is the subtle difference between each one of them, when we use it, and then all of this is just as a way to describe that now Redux at the end of the day, they just want is to make all of this state management updates synchronous. And if you have any asynchronous nature in your application, for some reason, you now in the example of the orders, all right. How important it is for us in the case of this e-commerce to actually keep track of the order. So, for example, by the time that package now is on its way, we can actually emit an event or send an HTTP request and then update that state properly. But this is something that happens asynchronously. And the way how we deal with is by using now middlewares. This is one of the most used case here, especially when you're creating now your Redux application is on middlewares. So before that, we need to understand, that's one of the reasons why I actually, as I look at this middleware and how you can create this thunk, to me it was like, what the F am I doing here? Okay. Well, the idea here is that first I really need to actually is take a look at the asynchronicity course, which is the reason why we are actually doing here, right? From Kyle Simpson, okay? Just to understand the conceptual, just to have the conceptual understanding of asynchronicity and the patterns around it, as well as the practical sense out of this. Why is this? Because this is something that, especially if you're going to build a lot of these web applications, you a lot of the time going to handle is this asynchronicity. Not only web application, but any application in itself that have to wait for data to arrive, or that needs to actually, or wait for data to arrive, or defer some sort of computation, or wait for this computation is done. So that's why first we'll look at now the parallel and async here, just to briefly describe that now from the parallelism in the computer science, from the computer science perspective, parallelism here, it means that you can now have multiple threads that in each one of those threads are going to now run is task at the same time. True parallelism is not a human, from the cognitive perspective, it's not a human thing possible. Cognitively speaking, here, yeah, cognitively speaking. So because we just only deal is with things that happens, that overlaps over time. So the way how now works in the parallelism actually works in the computer is, as I mentioned, that's truly parallelism, okay? That's what we have, for example, now CPU that has 4 cores, 8, 12, 16, 32. But if you can imagine that an OS needs much more of these threads to actually run in its basic operation, okay? So web browsers, traditionally, just a plain web browser, actually in the case of Chrome at 2024 in the Mac OS, it requires 4 threads to do this. So the subtle difference between process and a thread is that now a process is a program that is executing, which is something that I put here. So it's an independent program with its own memory, and it wants to actually see the gap here. The process is a program with an independent memory, or the process is a independent program with its own independent memory that can communicate with others through IPC, right? Or these inter-process communications, right? It can be file or signal or socket or unit sockets, okay? A message queue, for example, at the TCP/IP level. So it is important to understand that all of this process are just programs, like the browser. It's an independent program that has its own memory. In communicate with others through the IPC. All right, this inter-process communication. It can be, well, by files or signal or Unix sockets or TCP sockets, internal message of message queue as well. Whereas now the threads is this small unit of execution that now, exactly, a thread is a small unit of execution in a thread, in a program, right? So what is a small unit of execution in a program, especially in JavaScript, is a line, right? That statement. So this process or these threads can share resource across threads. Okay, so the point here is that each one of those processes, okay, so for example, the browser is running in one process, and then also the JavaScript engine is using another process. Between this process, they cannot communicate, so they cannot share data resource amongst them. They have to do that through the IPC, all right? And in the context of JavaScript, there is something, there is something called web workers, where is a particular process running in the background that now you can define is shareable resource across all of these JavaScript engine programs that are running on each one of these independent or different process, right? It's independent programs that have its own memory and its own resource. So that's a great thing for us as a developer, because we don't have to deal is with things like concurrency or things like parallelism, right? So that's a great thing for JavaScript concerns, right? Is that we don't have to worry about thread programming. It's like, hey, this is a small unit of work in my programs. I want you to do this, and then this, and then another one. So that's one where things started to have. That's one concepts like semaphores and resource share locking started to make sense and getting a very wild things out of that. So we don't have to worry about that, okay? And with the web workers, what we're doing is just trying to now make this multi-threading applications here, right? So fortunately, web worker give us these communications, okay, step through a synchronous event, and that is something interesting. So web workers, say perplexity here. Event model. You can have dedicated workers used for a single task. Shared workers can be accessed by multiple scripts, and service worker can act as a proxy between web applications and the network, enabling features like offline supporting. That's very interesting. But the web workers are a powerful feature in JavaScript that enhances asynchronicity through the event model, allowing the developer to execute tasks in the background without blocking the main thread. And they're not blocking the main thread because we are creating a different process, okay, that now are sharing this data across all of these different JavaScript process or this main thread. Now, this is not the role of web workers. Communication between threads and the communication between the main thread and web worker is done through the messaging system. Workers cannot access the DOM directly and instead interact with the main thread via post message and event listener. This design ensures that the data is passed safely and avoid concurrency issues since each thread operates in its own context. Okay, so what is the messaging system? In this case, What is the architecture? Messaging system. A messaging passing mechanism that utilizes two core methods. The messaging system operates asynchronously, meaning that sending a message does not block the execution of the code. The event loop manages incoming message. It's a fundamental construct. But all of this, okay, this workers, which is something that okay. Which is something that we have barely worked with this, right? This worker. But this thread is a sequence of instructions that programs follow. Because if the program consists of a single thread, it can only do one thing at a time. Exactly. Exactly, in a different thread. So you can start the task, then continue with other processing, such as handling user interactions. If the multiple threads can have the same shared data. In specific cases, worker and the main code run in separate completely worlds and only interact by sending each other messages. Exactly. If they run in completely different world, it means they run in different process. So why we are recording, why we are looking at this, you may wonder, right? Because here you can say, hey, I just want you to do this computation here in a recursive way, okay? And then put me the first 1 million names. Primes of length in quota. Okay. And here is because you are in the main threads, you say, hey, generate primes. Exactly. The programs become totally responsive because it's now running all of this instruction in the main threads. So where is our UI is running. So that's what happened. It will break. It will crash. Prime generation with a worker. Okay. Index style main generate yes. Okay. Prime generator with a worker. It's like, hey, in here, generate, which is a code here. Wait, what? Oh, this is finished. Here's when I have my particular code, okay, that by the time now that I'm reading is this in a separate process, which is part of the worker, and this worker is going to now run in this particular process. By the time I receive now this command, okay, and they communicate using the event loop behind the scenes, I'm going to now, in this particular process, generate this and sends that. So here we are using is now the power of this multi-threading programming, okay? But the that comes with its own trade-off as well, because now it's likely to see, it's like, hey, how can we now visualize this concurrency? How can we visualize this concurrency, bro? Share workers that allow you to share now from several browsing contexts, such as several windows, iframe, or even workers. As a way to share now data from this. And the other is, this is share worker, and the other service worker, which is now act as a proxy between this. By creating now a new process, there are intent, among other things, to enable the creation of an effective online experience, intercept network requests, and takes appropriate action based on whether the network is available, and update asset residing on the server. They will also allow access to push notification and background sync API. Service worker concept and uses. A service worker is an event-driven worker. Register against an origin and a path. Which is a background task that can be created via npm via script, which can send message back to its creator. Exactly. So creates a dedicated web worker. Create a dedicated web worker in a background thread separate from the main execution thread of a web application. The advantage of this is that its laborious processing can be performed in separate threads, allowing the main, usually the UI threads, to run without being blocked. Slow down. I'm working in an object created using a constructor worker that runs a named JavaScript file. This file contains the code that will run in the worker thread. In addition to the standards JavaScript sets of functions such as strings, array, objects, and JSONs, you can run almost any code. But in any case, this is now, they say, a separate thread. It is possible to run a script operation in a background thread separate from the main execution thread. Okay? Separate for this small unit of execution code. So in other words, it means that you are creating now and effectively a separate process. So if you say, for example, here, it is safe to assume that web workers run in a separate field, in a separate process. Let me actually ask to Claude again. No, that's not correct. Where workers run in a separate threads, not a separate process. Okay, this is an important distinction. A thread is a unit of execution within a process. Sharing the same memory space and other thread is that is a process. Through the web worker have their own isolated memory. Multiple threads can exist within a single process. Okay, so you can, okay, it's a, web workers, especially running a separate threads parallel to the main JavaScript threads, have their own event loop and stack, cannot directly access the DOM, and communicate with the main thread via message passing post message. This design allows for concurrent execution while maintaining browser security and stability. If a web worker crashes, it won't take down the entire browser process. So it is like the callback queue for the timers. So it is like the callback queue for timers. No, web workers are quite different from the callback queue for timers. Let me explain. Timers callback run on the main thread. Okay, go through the callback queue, wait for the call stack for empty before executing, and are part of the regular event. Web workers run truly in a parallel on a separate thread, have their own independent event loop and call stack, and execute code simultaneously with a main thread. Don't wait for the main thread call stack. So it is an okay. So this is an independent. Well, it is. Okay. It is similar to the queue or to the microtest queue of the promise. No, because promise as well run in the same no, because okay, promise run in the same main thread, have priority over the macro task. Regular callback queue can block the main threads, and can block the main thread. When our worker say, hey, I'm going to run in a separate thread, I'm going to run in a separate unit processing, I'm going to run in a separate thread. So what's the difference between a thread and a process? I know that the process has their own they have their own memory space isolated from other process, have their own system resource, file handles, network sockets, etc. are independent execution units. If one crash, other keeps running, have more overhead to create and manage. For example, each browser tab typically running in its own process. That makes a lot of sense. Okay. So each browser, okay, so each browser, come on, mierda. ¿Esto sigue? Okay. So in threads, share memory space with other threads in the same process. Share system resource of their parent process. are lightweight than process and can directly communicate. A helpful analogy is a process is like a separate apartment with its own kitchens and bathroom. Threats are like roommates sharing the apartment. They share resources but can do things independently. They share resources but can do things independently. If one roommate threats cause a fire, the whole apartment process is affected. Different apartment or processes are isolated. Problems in one don't directly affect that. Oh, okay, I can create a diagram. Okay. In this process, you can have is now several threads that can do things independently and share now. Mm, 'They are threats. Mm-hmm. Mm-hmm. 5 years old. I'm asking this kind of question because I need to actually is understand. When you play a game on the computer, the game is like the kitchen process. Different helpers inside the game, threads do different jobs. One makes the music play, another. Beehive. The hive is the process. Bees are the threads working in parallel, share same honey and research, different roles but same space. 3. Thunks rocks process, the main support system and branches, threads, share the same nutrients, work in parallel for photosynthesis. If strong diet, all branches dies. Mm-hmm. Think of an anthill. What the hell is an anthill? Ah, anthill. Oh, anthill. Hormiguero. It's an anthill. Oh. Okay. Beehive. Beehive of an anthill. Okay. That's a good analogy here. When you need to describe is the difference between a threats and a process. So a process is this independent programs that can run what it is independent. This is an independent program that can run with its own memory, its own research, okay, and they are not shared with others. So how can different process can communicate together? Exactly, it's collectively to the inter-process communication, bro. Whether it's pipe or sockets or share memory. Inter-process communication, whether it's through pipes, sockets, or share memory. Message queue, message map, and signals limited communication. So each method has trade-off: pipe, simple but unidirectional; socket, flexible, good for networking; share memory, fast but needs synchronization; message queue, good for distribute systems and signals. Think of it like pipes are like the water pipe, one-way flow, and sockets are like phones, two-way communication. Shared memory is like a shared whiteboard. Message queues are like postal services. Message queues like postal services, like Correo Argentino in this case. Signals are like emergency alarms. This is something interesting and important to actually wrap my mind around this, because this computer is made of different processes, of different independent programs with its own research, okay, and they are isolated in each one of them. A good analogy of this is like the beehive is the process, and all of these bees inside of it are threads. Another good analogy is the tree is the main process, where all of its branch is threads. So if the tree dies, all of the branch dies as well. So another good analogy is the anthill, where the anthill is a process, okay, and the ends is all of these threads that can now do things by their own. So this real life analogy is something important to have in mind, okay, because you might wonder, another question is that, yeah, but how this different anthills or beehive or trees communicate each other, or in this case, how this process in the computer communicate each other. Oh, they do this is thanks to this inter-processing communication, or inter-IPC. Inter-process communications. Interesting. Inter-process communication here. Where you have pipes as a way to now send data unidirectional from one process to another process, or socket for real life communication. Okay. Then you have shared memories, all right, where the key thing is that you have now to keep in synchronous. You need to have that synchronization, share whiteboards, okay. Then you have message queues, which is pretty much like the post signal, which is pretty much like the post signal or like the post service. And then you have signal, which is for alarms, for emergency. This, my friends, is something very, very interesting, because with this particular knowledge here, as a way to now wrap around your mind between is process, between process and threads, all right, as a way to make sense of this asynchronicity. And so some of these real life examples, now it makes a lot of sense when we talk about that the web worker create now a thread, okay, which means that this particular thread, which is an independent process, is an independent task that can run inside of the process, where now it can access to all of this shared data or resource, okay. But now these threads here, okay, but now these threads here, okay, but now these threads where now these threads it's a worker, okay. That's what they call now worker, who can execute tasks independently while sharing the resource with other workers in the same program. So this is okay. So now these threads or workers can execute tasks independently. So this is create now a new different worker, so the web workers is creating now is a new thread or a new worker that can run tasks independently. So it means that while the main UI is now running on a particular thread, on a particular worker, you can have other workers running in parallel as a way to provide now this this parallelism. However, when we need to is deal with this, so okay. So process is an independent program with its own memory that can communicate with others through inter-process communication. It can be file, inter-process communication. Okay, holy hell, here we go. Inter-process communications, right? Inter-process communication. It can be through pipes, okay. It's unidirectional, socket, bidirectional, memory, like a whiteboard. Why can't be black? Oh, here we go, bro. No, here we go. Message queue, like the post service, okay, and signals like emergency calls. So a thread is a small unit of execution in a process known as a worker. It shares resource across threads. So with this subtle distinction, which is something very, very important, yeah, absolutely is important, at least to me, as a way to now understand what is the subtle difference between the process and the threads, okay? Especially as a way to describe that. So hey, a process is an independent program with its own memory that can communicate with other processes through the EPC, internal process communication. It can be is unidirectional, okay? Hey, hear me. I don't care. What you have to say about French toast with you, right? It can be pipes, unidirectional. It can be socket, multidirectional. It can be memory, pretty much like a whiteboard, but that's when you have now this synchronization problems. Message queue, pretty much like a POS service. Okay, so you send a package and you send another package and another package, and then you reach to each one of them, go through that particular destination. So the POS service actually is the one who coordinating this. You also have now signals like this for emergency calls. It makes a lot of sense, and now especially here on this particularly on the JavaScript here. Okay, so now here in JavaScript here, when we talk about now is process and threads, and as you can imagine that even though you can have multiple threads in your CPU, is not enough, because by just only by running is a what? Just by running is Chrome with a single tap is actually using 4 threads. You know, only he's using is 4 threads. So this particular process. So now it becomes here with the web worker concepts. The idea here is to actually bring now is parallelism to the language by allowing you to run is a thread or a worker. A good analogy of this is like this ant hill, which is the process, where now all of these ants are the workers, where they can now share resources and do tasks independently within the process. Another good analogy is the beehive, okay, where the beehive is the process, is this independent space, is this independent process that is running with its own research, with its own memory, honey, among other things, where now workers can actually do things independently by sharing research among them. That's quite interesting here as a way to describe that, and then now a more practical aspect of this. Okay. Jesus. Okay. Interesting. Very, very, very interesting, by the way. So with that knowledge, okay, and that after all, especially when we're writing is our applications here in the JavaScript lands, where now things are running is a line after another, is a single thread, right? So it execute line after it execute our code one line at a time. Web workers want to try to bring now is the multi-threading programming to JavaScript, but they just run is a different threads. But the run is practical. They just pretty much run is their own different, in a different process. You can think of this, right? But this is a thread that has its own set of registers, its own event loop. Exactly. Web workers run on a separate thread, executes truly in parallel, and don't block the main thread because it has its own resource, bro. So web workers running truly in parallel on a separate threads have their own independent event loop and call stack, execute code simultaneously with the main thread, and don't wait for the main thread's call stack. In theory, you can spread those instances per threads and simulate parallelism, but they can communicate each other. Especially with this JavaScript code. So in any given instance, you're running one line of the JavaScript code in the JavaScript engine. You in theory can spread those instances per thread and simulate parallelism. Yeah, in a given instance, all you can do is this. So web work is an attempt to close the gap by spinning an entire new process on a thread. But that's not JavaScript. That's a web browser or no thing, right? Because web workers run truly in parallel in separate threads. They have their own event loop and call stack. So it has their own JavaScript engine here, and execute code simultaneously with the main threads and event line. So the web platform defines the notion of a web worker. Spin up a whole new process on a threads of the JavaScript engine. That's what it's doing. It's like, hey, spin up a new process on a thread of a JavaScript engine, of the JavaScript engine. That's exactly what it's doing here. It's like, hey, spin up a new process of a thread of this worker in a JavaScript engine. Holy moly. So as far as the JavaScript is concerned, they don't know about each other programs. They are not sharing variables, they just overlap each other. The good news of this is that we don't have to worry about this parallelism, okay? Dealing things with now semaphores or taxes, new taxes, shared resource lockers, and all of that wildness. So fortunately, web workers give us the communication step through asynchronous events, and they have to communicate in this event loop notion, because at the end of the day, this is actually how we come now is dealing with this parallelism here, or the illusion that here we are now processing things in parallel. What we're not. We're using is the event loop. However, in concurrency here, okay, concurrency is the ability of a system to deal with multiple tasks that overlaps in time. Okay, you yourself have the ability to work with all of these tasks that overlaps at each time. So for example, when cooking and your mom calls you, you are dealing with the cooking as well as the calling, right? So it's the complexity of dealing with multiple tasks that overlap in time. For example, when your mom calls you, you deal with the cooking as well as the calling, that needs to take care of. So every async pattern we have seen can be achieved with the callbacks in this course. Exactly. So in this course, every async pattern we're about to see can be achieved with the callback, but we're going to see that it's insufficient for expressing the higher and higher order of complexity we need to deal in JavaScript applications. And our JavaScript programs are failing behind because we need these high order patterns, and if we're not disciplined to learn and apply them, we'll continue to use the things that work for the sake of work. So the next level of competency for JavaScript developers is to be strategic and tactical in your approach of concurrent management in your asynchronous applications. All right, okay, good. So with that, I'm not gonna dive deep into the callback here, right? Or in the callback. This is particularly the tool that web platform provide in JavaScript as a way to handle is this callbacks, or this continuation of the code at some point in the future, right? Because by expressing is that continuation of a program, it can be something very not readable. All right, we're not also solving the true problem of what callbacks provide to us, especially when we now to deal is common user scenarios like making multiple requests in parallel, waiting for them to come back, coordinate the response, response as they came in, okay, respond as soon as they're possible, and then provide them in the proper order, right? And make sure things happen in the proper order. All of these coordination things, okay, is one of the things that we already saw, and we had that's what we created is this global variable as a way to keep track that when by the time that all of these requests that were made of, we actually keep track of them in this hash map, and by the time they come back with, so we now are able to add in to our array in the proper order. So by the time we get is the last of all of them, we're now going to show them in the proper order, right? And all of this coordination problem, because that's what an async is all about, is this coordination problems. It comes with this two set of problems, especially with using callback. Is the inversion control, because it's now we have two portions of a code. The first is the one we're going to execute right now, and the second one is at some point in the future, and we express that using callback by saying, hey, this portion, this second half of this code, you put them in control of how and when they're going to run, right? That's one of the issue with this, right? So you delegate this to someone else, and that's when the trust issue came here, is that when this is going to get, so when this is going to run, for how long it's going to run. I want to do this not too many times, I want to do this not too early, not too late, not too many times, especially not too many times, not too few times, not lose the context, no shallow errors, and the list go on and so on. So that's one of the reasons, that's why we make sure here a particular problem here with this way of how now you are going to handle is this asynchronicity in e-commerce applications, and how now you have to pass through all of this set of layers that are in a company to actually prove that. So another problem is that they are not reason about, they're not reason able. Because now you know that your code is gonna run one line at a time. That's what JavaScript actually do. And there are some attempts to try to actually make this a little bit more reasonable, right? But some non-fixes. You have now the separate callbacks, then you have now the error first style, where the first argument is the error here, and then you have now the nested callback as a way to actually pass this nested applications. And then we started to see thunks, which is now a function that is a wrapper around a thunks is a function wrapper that has everything that it needs to, and you only to get a value back. This is from the synchronous perspective, whereas from the asynchronous perspective, which is when things are much more interesting, is that I got everything that I need to. So by the time now I get that value, I want to now pass a callback to actually get it from. So this is something interesting, because with this particular pattern, which is mind-blowing, I also look at that particular exercise. Is like, holy moly, with this way of how you can now coordinate using your tools, which is closure here, a lot of the time, this is the way of how you can now coordinate is the response here. So you now abstract is time from the consideration of your program, which is time is the most important, is the most complex aspects to deal with. Okay. Damn son. And then we were able now is to make this code a little bit more reason about. We haven't solved the problem of inversion control, okay? But we have made our code much more reason about, more readable about. So that's one of the outcomes that thunks provide us. Is by having this, is by maintaining the state of our application. They don't improve callbacks, none of that. They only make is the code much more readable to handle asynchronous operations, to handle the asynchronicity. But it makes our code much more readable here with this thunk, because you only define as a thunk for the plumbing, and then for the use cases, for the consumer. That's what is. That's exactly what I'm using here a lot. A lot. A lot. That's exactly what I'm using here a lot, man. It makes a ton of sense. But again, it's by maintaining is the state. It doesn't improve anything on the callback and none of that things. It just makes the code much more readable to handle this asynchronicity. So now this token can now is allow us to make the asynchronicity much more readable, because now with this particular function you can actually export here and there, and actually by the time you get that, you use a callback out of this. Jesus fucking, there is a lot of things going on here, and that's why you need to make sense of this, and that's what you need to make a lot of sense out of this. Oh yeah, it is, bro. Okay, well, that'll be all for this video. Take care.